I mean, this is the best attended oral that I've ever had. The only difference is it's not really an oral. The university has discarded orals for masters, but our students still have to present in a public forum. So given the topic, given the relevance of what Thomas has done, I thought it would be a good idea to invite as many as possible people. Just to also give you some of the results that he's obtained, especially given the resurgence of, or at least the emergence of wireless technologies in the IoT domain. And we're getting exactly the same questions from everybody. Which technology is the least battery power? Which one has the best range coverage? So that's what Thomas has done. Okay. So Thomas, before you start, just to check. Yusuf, are you guys okay? Are you following this?
Supposed to get me live.
Where's your mic?
It's all on this laptop, yeah.
I'm going to assume that they're okay. They were on 5 minutes ago.
Yeah.
So yeah, Thomas has 20 minutes, and then we're going to take some questions afterwards.
Okay. Thank you all for coming out, and thanks for those live stream. So as Tina said, my thesis is about the evaluation of next generation low power wide area networks to replace GSM in IoT applications. And yeah, as Tina is my main supervisor and Lawrence is my co-supervisor. So just to give you an outline of what we'll be discussing today is, so we're first going to look at the background information of what LP-WAN is and how it fits into the picture, and then I'm going to look at the test systems that are used to actually compare the different technologies in real-world applications. And then we're going to jump right into my results that I got from all of the testing. And then we're just going to look at a comparative conclusion of all of the different networks, how they fit into the different comparative metrics, and then apply those metrics to different use cases and check, okay, so which use cases are typically required by different networks and so forth. And then just look at future work. So first off, the background information. So LP-WAN fits into the spectrum of, it has the same range as GSM networks, while being much lower, offering much lower power consumption. So LP-WAN networks typically consist of one directional communication from the device to the gateway, uplink-centric, with low data rates between 10 to 12 bytes per 10 minutes per hour low, not necessary for media streaming and so forth, with really good power usage, 5 to 10 years max battery life. So these devices are left in the field and expected to run on end. And then just really low cost. So you want the economy of scale, you want a large scale deployment of sensors in the field. That's the core values that LP-WAN strive to uphold. So to test all the network, I just determined there's 4 networks that I want to test, which was the GSM network. Basically, I tested GPRS with the MQTT application running to my AWS server. And then I tested LoraWAN specifically in the context of the Things Network. And the Things Network is a community-driven project which has gateways all over the world. It's a community of members putting up gateways for any devices to connect to and maintain a network where devices can transmit messages and so forth. But that uses the LoraWAN protocol stack to transmit messages. And then in terms of I tested NB-IoT as a competitor to the LP-WAN market, specifically the license spectrum LP-WAN market. And this is rolled out by mobile network operators such as MTN and Vodacom and so forth. We'll get to that in a second. And then I tested Sigfox. Sigfox is also a low-powered wide area network utilizing the unlicensed ISM spectrum band, which is so it's also meant for low throughput applications, as the ISM band has 1% duty cycle limitation. So all of these devices were transmitted to all of the data sent from these devices were concatenated in the AWS instance with the MongoDB database to store of the data which can be used. And then I have access to all of that data. And then just to quickly show you the test device that I used, it's a really basic device with an antenna, a microcontroller, and the different modems and a battery. And this was meant so that you can use it in different applications, from asset tracking to pulse counting and so forth. Just a bare bones system that just consists of the basics to test only the core communication module. So Yeah, from that I want to move on to the base stations and the actual network that these devices use. So first off, with the help of NTA and ZTE, we launched the first NB-IoT base station August of last year beyond the engineering building's roof. It is worthy to note that this is still a testing site, so it's not a complete NB-IoT setup, and like there's only provisioned specific SIM cards for different devices. And then at the start of my thesis, the SquidNet network wasn't completely covering Stellenbosch, so without SquidNet, we launched a new Sigfox base station also on the roof of the engineering building. And then, thanks to the help of actually JetMS in the car, we launched the small LoRa Things Network Gateway, which is covering Stellenbosch now. It is worth to note that it's currently offline, but it will in the future be coming back online. So yeah, jumping right straight into the results. So this is the maximum coupling loss. And the maximum coupling loss is the amount of power that can be lost between your transmitter, signal attenuation between your transmitter and your receiver. And this is important as a larger maximum coupling loss will provide better coverage in deep indoor situations. So devices that are in the basement of houses and so forth can still be connected. And it's worthy to note that so this was tested by checking what is the maximum packet delivery ratio, or what is the maximum received signal that I can receive while still maintaining 100% packet delivery ratio of packets from device to the gateway. And it is worth to note that Sigfox and NB-IoT performed really good in this application, as they have a really large link budget. Specifically, NB-IoT has the larger transmitted power at 23 dBm, which helped to increase the link budget. And worthy to note also, G4S didn't perform as nicely. And then the power consumption. So this is a bit of a controversial topic, but I tested the different modems, specifically the transmit, receive, sleep current, idle current of each modem on its own, and then compared these values to the theoretical data that I got from the data sheet and the data rates of the different devices. So LoraWAN Spring Factor 7 showed really good results, as it has a really low time on air, so the transmission current is really low, while Sigfox has 3 repetitive transmissions, which cause the transmission time to be really high and increase the power consumption of these devices. It is also worth to note there's a large discrepancy between the NB-IoT's theoretical calculated power consumption versus the empirically measured power consumption, and this is due to it's a testing network, so the time that the device stayed active to receive messages was way longer than the theoretical time, and this is still a testing network, so it will improve in the future. And then, so to measure throughput of the different devices, I measured the LoraWAN's time on air of each message, and as it is limited by a 1% duty cycle in the ISM band, this is your throughput limitation for each device, just with LoraWAN. And then further on, the Things network limits this time on air to 30 seconds per day in conjunction with the limitation of the ISM band. So that is your maximum packets per day for LoraWAN. And then Sigfox is limited by business model to 140 12 byte messages per day. That's the limit. So what I did was I tried to determine what is the maximum sequential rate that you can transmit messages at. So that's why I measured the different bit rates of the different technologies. And then NB-IoT's transmission speeds and current, so the transmission speeds of the different in different signal quality situations. So NB-IoT's throughput rate or transmission rate is dependent on the network conditions, the amount of devices connected, the signal quality environment. So the values will score all over the place. So I just tried to show you, okay, so what is the typical values that I got from the base station? As in, this is not the theoretical values that is listed for NB-IoT, but as I said, it's still the NB-IoT's base station is still under development. So we'll see maybe in the future. So to check for the throughput is the maximum packets per day that the device can handle. So NB-IoT is vastly superior as it is operated in the license spectrum. So there's no duty cycle limitation at all, while LoraWAN and Sigfox actually suffer in that regard. So then for scalability, NB-IoT, Sigfox, and GPRS scalability is based on existing research, while LoraWAN scalability's analysis was done with a simulation that is based on the pure LoRa protocol. And this is a simulation where numerous end devices is connected to a single base station, transmitting a single 12-byte packet every 1,000 seconds. So this, and then I determined, okay, what is the maximum number of devices possible per base station while still allowing a 1%, just a 1% packet error rate. And that is the results. As you can see, LoRaWAN suffers scalability issues, and that is verified by other research as well. And then in terms of different antennas tested, so typically IoT device manufacturers tend to use different antennas. So I decided, okay, I'm going to test which of the commonly used antennas perform better. So all of these antennas were tested in an anechoic chamber and then with a network frequency analyzer to determine what is the performance of these, the theoretical performance of these antennas. And that was tested again in field with the different technologies in a line of sight environment. And it is worthy to note that 3 dBi dipole antenna performed best with different technologies, while the little 9 antenna performed the worst, as it was a more cheaply made antenna actually. So and then in terms of polarization, so typically devices tend to be placed in the field in different orientations. So I decided, okay, I'm going to check if there is any loss of received power if you place a device in different orientations in the field. This is also a test done in a line of sight environment with different, with a vertically polarized receiving antenna and vertically polarized transmitting antenna. And it's worthy to note that Sigfox and LoraWAN suffer the worst performance loss due to the polarization mismatch, while NB-IoT performs best as it uses a dual polarized receiving antenna. So yeah, that's that. And then I tested the near field interference of the different devices. So this is the near field interference typically has an effect on your VSSR of your antenna, which increases or decreases the efficiency of your antenna. So this is just done for IoT device manufacturers to check, okay, remember to not place your device close to in a metal enclosure as typically required by energy meters and so forth. And then I tested the path losses of different technologies at different distances from the gateway with a GPS receiver based on the end device, and then plotted that versus the theoretical free space path loss of the device. So this can be used by network operators to check, okay, this is your maximum practically measured path loss in a urban environment such as Stellenbosch. And that will be helpful in terms of where to place your network gateways and where to place devices and to ensure that end users actually get decent coverage. And that's the same plot that I did for Sigfox. And then just a quick map of the different technologies coverage in Stellenbosch. It's worthy to note Sigfox performed the best all around, as there is 3 different base stations covering the whole of Stellenbosch, while TTN's coverage was not that excellent, as there is only 1 or 2 gateways covering the whole of Stellenbosch, which is still, it can be better. It can be improved in the future. It's also worthy to know that GPRS performed by far the best coverage in Stellenbosch, with really good coverage all around. And that's due to the legacy infrastructure of the GSM network available in Stellenbosch. And then NB-IoT, there's only 1 base station, which is located here in the engineering building. Although there's only 1 base station, it still provided relatively good coverage all around. And then lastly, for my comparative conclusion, I checked, okay, so to summarize all of this different performance metrics that I tested into a single overview where you can compare technologies. So it's really interesting to note that NB-IoT performed really good in all aspects: downlink throughput, uplink throughput, scalability, and your maximum coupling rate. It only lagged behind in battery consumption. And I think that's something that can be improved in the future when the commercial NB-IoT network actually launches. LoraWAN, as I said, there's no firmware over-the-air updates available, as the throughput is the 1% cycle limit is a bit of a limitation. Same goes with Sigfox. And yeah, GPRS, it's becoming, it is a aging technology which is being phased out by 3G and 4G technologies. So that is interesting to note that this is your new alternatives to GPRS. And then last up, just typical use cases of these technologies. So these use cases are typically battery-driven applications such as smart bicycles, smart parking, and so forth. And these sensors require battery lifetimes of 5 to 10 years. So that's why GPRS performed not the best in this application, while LoraWAN, Sigfox, and NB-IoT actually performed okay. Yeah, as I said, in the future, NB-IoT might improve its technology, but there is certain applications where you would still require high throughput networks, such as point-of-sale services and healthcare services, where it's critical that you have the quality of service and the network available. So, yeah, in the future, just my research, the test devices that I built was quite power efficient and worked relatively good. It's important that if you want to place these devices in actual networks and use them as applications, an improved battery and regulator and microcontroller choice would be a great start, so that you can improve the battery life, as the modems are quite optimized. And then in the test system, the LoraWAN gateway is currently offline. That's due to the high cost of mobile data for the backend of the system. We are currently reallocating the gateway to a different site where there's ADSL connection available. And then in terms of the NB-IoT modem, so the NB-IoT modem was tested with just UDP datagrams sent over the network. So a co-app integration would be interesting, as it's a low-powered application of HTTP. And then lastly, a front-end web development where you can actually see all the data collected by sensors would be interesting to add. And I just want to thank MTN for sponsoring this research. And yeah, if there's any questions, there's definitely some questions. Thank you.
Let's take questions from this side first, and then I have about 4 questions from
Okay. Good sir.
Sorry, just a question on your power measurements. How do you measure your current?
Okay.
So that just did you calibrate it?
Okay, so the current measurement device that I used was actually U-current. It is a highly sensitive current sense resistor setup. So you have a current sense resistor that you can configure in 3 different settings. So you have 10 kilo ohm, 1 ohm, and 10 milliohm setting. So that you can measure in the milliampere, nanoampere, and microampere range, and that it was calibrated to about a 1% accuracy. So, and as you can see, there is data sets available that verifies this the power consumption measured by all of the devices with the data sheet's power consumption, and so the voltage drop across the current sense resistor was amplified by a 2-stage op-amp circuit, which has a really low offset voltage. And these the op-amps are really quite expensive, as they're really highly tuned to provide an offset voltage of less than 1 millivolt. So eventually, when you measure your current consumption, you get a value that's relative to your current that's flowing to the modem. So you either say you have 1,000 milliamperes flowing to your NB-IoT's modem or your GPRS modem, and then that correlates to 1,000 millivolts. So it's really high accuracy, and and it relates to the actual data sheet values.
Thank you.
Yes, yes,
I actually have a few questions, but maybe can you just go back to your antenna comparison?
yes.
I think I just want to confirm what I heard. One. You said the number 3 was the best,
Yes.
and number 5 was the worst. And number 5 is 3 dB gain. Number 3 as well, 3 dB gain.
Yeah, so it depends on which technology you actually use. So some of these, so you tested a network frequency analyzer of the different antennas, and your VSR is your reflected power back to you from your antenna. And some of these antennas were more optimized for GSM, for 800 megahertz and 1800 megahertz and so forth, while some of the antennas were more optimized for 868 megahertz. And the antennas that were optimized for 868 megahertz, in the network frequency analyzer, it showed that the values weren't completely at 868 megahertz, and there was a large difference between that and the actual data. So it showed around like 800 megahertz optimum point of operation instead of the 868 megahertz point of operation.
Yeah, what I'm asking is, I'm actually looking at this the same issue, but on the gateway side, because antenna on the gateway side is also important.
Yes.
Normally people just use the normal one off the shelf. So that actually sort of brings me to my second question. You had a graph there of your link loss versus distance for LoraWAN and Sigfox.
Oh yes.
Yeah, that one.
Yes.
What I wanted to know, the path loss. How do you calculate path loss? Do you use RSSI? Do you use noise ratio?
So it's based on the RSSI values of the different devices, and then that is using the link budget calculation where you have your path, so you have your transmitted power, received power, and the gain of the different antennas. So it is assumed that the antenna gain is 3 dBi as per data sheet spec of the device, and then 2 dBi from the receiving antenna. But it's not always, you always have that little variance of your antenna, your antenna's radiation pattern isn't always 3 dBi at different locations.
Yeah, so actually what I want to know, do you take the signal to noise ratio into account there? Or?
Yes. Okay.
My question will be easier. Firstly, congratulations on the research. I think it's very relevant, and it does touch on a couple of very contentious issues and areas. So just a couple of very practical questions regarding, there's a promise for a low power wide area network from a range point of view to give you a much higher range than GSM. So that's the question, whether it's something that you've looked at. And then with respect to your, let's call it penetration, what we call deep coverage. Did you test the penetration? I didn't pick that up in the...
So for different objects have the penetration through different objects at different. So that was a test that was considered, and I actually tested it, and the practical results weren't accurate enough to justify it. So you would rather test the penetration of these different devices in a network frequency or in an anechoic chamber where you don't have reflections coming off from different angles, and you know where your transmitter and receive base station is. So practically measuring these values isn't actually feasible. However, like that's maybe even further future work that you can go through is to test the different penetration of the objects. And then, as you said, the practical range. Yes, if you take this value into consideration with the higher coupling loss, so that's the maximum attenuation between your device and the device and the gateway. If you take that into consideration, that means you can have a higher path loss, which correlates to a higher distance and a further range of your end devices.
Have we done tests on 10 kilometers or more?
Yes. So there was actually quite interesting. JP May has created a really interesting application called the Think Network Mapper, and over there he had a gateway in Somerset West, and that picked up data with LoraWAN up to 44 kilometers, I believe, from Somerset West to Durand. So, and then practically, I've also tested these networks. The NB-IoT's coverage came down to, I think, 6 or 7 kilometers eventually, from here in the engineering building to Daphne Park.
Then just the last question, attribute security. Security.
Yes. So it's really interesting to note. So NB-IoT inherits all of the security protocols that is inherent in LTE applications. So you have your whole base station application security with the modulation, decryption, and so forth. LoraWAN has its own, and Think Network has its own set of private keys. So you have an access key and an application key that is built into the device, and that encrypts your data from, I believe it encrypts your data from your end device to your back-end system. And then Sigfox's security is, it's secured from your end device to your, from the base station to your end device, and you can therefore, on top of your own messages, you can build in your own encryption standard as if you want to. And there's also other encryption, there's also other security protocols. So you have message counters that checks, okay, so it's not like a DDoS attack where devices just transmit to a gateway. So there's specific counters individual to each device. So it prevents random devices from actually interfering that. Another question?
Just a quick question related to the use case. With asset tracking, what sort of metrics did you use?
Okay, so for asset tracking specifically, I looked at asset tracking such as container tracking and so forth, where these devices are placed in situations where they need to be relatively small and and battery powered. So that's why I decided, okay, no, GPRS is not the best solution for that application. Yes.
Okay, just a question. I'm not too familiar with frequencies and penetrations and whatnot, but logically, they all run 800 or 1800 megahertz. So why does that not? Why do you get a better penetration with the 800 Sigfox, for argument's sake, than the 800 megahertz TSN?
Okay, so yeah. Sigfox and LoraWAN is operated in the 868 megahertz spectrum, while GSM and NB-IoT is 800 megahertz. It depends on the network operator. And so the thing is, what I checked was the maximum coupling loss instead of the actual penetration. So I didn't test penetration, but I've tested these base stations offer lower receive sensitivity. So you can specifically look with LoraWAN, you can receive signals up to, down to 20 dB below the noise floor. So these, so you really get a better coupling loss in terms of devices, as the receive sensitivity is quite low, specifically for LoraWAN and Sigfox.
Could you maybe go to those slides where you show how the transmissions are different? I think that will also explain. So even though they're on the same frequency, they just use totally different methods of communication. I mean, your appendix,
Right.
and that's related to your power calculation, but it gives you a good idea of how they differ. So that's the transmission profile of.
Yeah. So that's the power consumption. That's the power consumption profile. So as you can see, LoraWAN Spring Factor 7 has a really low time on air, so it's not a lot of power consumed by the different devices, while the Spring Factor 12 is a longer time on air. Sigfox has the 3 repetitive transmissions, which contribute to the high power consumption of the devices. And the NB-IoT's power consumption is about 220 milliampere, and this is the complete transmission current cycle of the NB-IoT device, which contributes to the high power consumption. And it's interesting to note that the amount of time that the device stays in receive mode, once it can still receive messages from the base station, was 250 seconds, which is really long in terms, but that's still network dependent. So if base station operators decide, okay, no, we'll implement something better, you can get 2 to 5 second window, which is just going to reduce the power consumption quite drastically. And that's the typical current consumption of RSC window which is over here. That's basically this piece of current consumption profile. And that's verified by the data sheet. So this is the data sheet for the modem, which suggests that the RSC connection window was around 20 seconds, but it's not possible to change at all. So Timothy,
And the GSM or GPRS?
so I didn't have it on here, but yeah, it's a bit too high. So GSM typically, GPRS typically is around 1.8 amperes transmission.
That's a very short.
Very short period, but there is the constant paging of these devices that you need constant relay between your device and your base station, and that contributes to really high power consumption. The device needs to be active most of the time.
Yeah.
Okay.
Can I take a few questions from the,
Yes,
the stream because they're streaming in? Okay, so the first thing is, please confirm the CAT and band of the NB-IoT base station used, and if power saving config was enabled.
So yes, power saving configuration was enabled, and the windows between the different transmission cycles was longer than the extended discontinuous reception of the device. And then it is CAT NB, LTE CAT NB type 1, and it's in band 8 currently.
Okay, the next one is in relation to the penetration, but I think that was already asked. Then any comparisons done relating the telemetry or radio modules of each technology, particularly relating to the availability and cost?
Okay, so availability and cost, that's actually an easy question. So module cost for Sigfox is around 35-40 Rand, really cheap. LoraWAN's modules is more expensive, or you get two options, a cheap one, which is 60 Rand, 60 to 80 Rand, depending on the supplier. And then you have the higher cost modem, which has the full LoraWAN stack in it. The other modem is just a LoRa module. The one with the full LoraWAN stack is 250 Rand. Pricing for the NB-IoT modem is not, I have absolutely no idea. It's still one of the things that it's not currently available on the market. I'm not sure. I got my $12, yeah.
Exactly $12.
Exactly $12. Okay, we have the expert over there. So I got just engineering samples for my research, and then but that is the typical range. And prices will go down in the future as the economy of scale increases the amount of end devices. And then GPRN modules, I believe, is 350 to 400 Rand. It's some. It depends on the.
Quite cost effective.
It depends, because you get the cheaper SIMCOM 800C modems, and then you get the higher cost your U-Blocks modems.
So you're going to go there, just so if I can just add, so anything from, let's call it really cheap, about 80 to 90 Rand, up to about 175. So you're looking at sort of like SIMCOM, and then up to U-Blocks.
So, and that's a nice thing about, it's not only the modem cost that you need to consider, it's eventually your the data cost as well. Whereas the Think network has a free network for you to use. You just need to, if there is no gateway available, you just need to place a gateway, and that's a once-off cost. Okay, without the ADSL connection, but typically that's available. And so that's a free network and then if you have a lot of devices, specifically with Sigfox, you pay per device a yearly subscription fee. And pricing schedule
is 100 or so.
100, yeah, that's what I had in mind as well. So that cost can add up eventually. Yeah. Yes.
So just on the Sigfox, I can help there as well. So you're looking at a platinum package on Sigfox, which is 144 up, 140 up, 4 down.
Yes.
And there you're looking at the moment, the platinum package is, it would cost you, if you had an annual package, just year on year, would be 280 Rand. So 140 Rand device registration per annum, and then 140 Rand is your subscription fee.
Yeah. And that's also dependent on the amount of devices that you actually have available. So if you have a large scalable, you can pay less. And then pricing for NB-IoT, also it's still in development phase.
So the next question is from Paul from Spronsen, writing in from the Netherlands, I think.
Yes, it comes to them.
Technical. Okay, so technical. I'm going to ask a question. So he's asking, you said the target is 5 to 10 years battery life. Did any of the technologies disqualify themselves due to being unable to meet this requirement economically?
So technically NB-IoT, but that is not accurate values currently. It would be interesting to see how NB-IoT fares in a commercial deployment where you actually have base stations that is regularly available to actual ID device manufacturers. So theoretically, NB-IoT can achieve that the power consumption target. However, we'll need to see. So my thesis was not on optimizing networks; it was on testing networks. Yeah. Any last questions?
Yeah, I was going to ask you another one. Yeah. On your use cases, can you just go through your use case slide?
Yes.
The topics that we took into consideration for the smart agriculture use case.
Yes.
Just give me like high level.
Soil sensors, you have water pump, water flow measurement, you have windmill speeds, and like there's a lot of tank levels. There's a lot of sensors that you typically want to employ in agriculture that need to be. A farmer doesn't want to go to his farm to his livestock and charge the sheep every day. That's basically what it comes down to. So you need really low power consumption for these applications for that extremely long battery life. That's why I disqualified GPRS. But if there is certain applications where GPRS might be more applicable, if you have power, and in farming situations, you have absolutely no mains powers available on the farm anywhere except the household. So, but there is applications if you have a weather station and a base station where you, or an end device which has main supply power available, and you want to add maybe a weather station with a different loggings and more accurate data sent every 2 seconds and so there you would have GPRS as a better option.
I don't think quite disqualify, right? GPRS is poor for asset tracking.
Yeah, that was the same question as Daniel said as well. So for asset tracking, I specifically looked at containers and small small batteries that is you want a small device eventually to stick onto the asset, and that tracks it for the rest of its lifetime. So specifically like Sigfox and LoraWAN, you can have these devices this small with a really small battery life. With the really small batteries, you're not going to have that excellent battery life, but you're going to have a really small sticker you can just tag onto something, and it can track it for the rest of the solution. And then another interesting thing is actually with Sigfox is actually really good for asset tracking, specifically with container tracking, because the Sigfox network is globally deployed. So if you have a device on different continents and that container comes into the harbor and there's a Sigfox network, that network picks it up and it tracks it from there on. So it's a global integration with your shipping. There's actually companies that do luggage tracking these days, where you track your luggage via the Sigfox network.
There's just one last comment about utility metering.
Yes.
Utility metering is not about one measurement every 10 minutes. I mean, nowadays electricity meters are streaming all the time, especially in high intensity power distribution. So you can't do that with all the other networks. I mean, GPRS or NB-IoT would be the best option for that.
That's definitely something I need to consider. Yeah, so specifically I'm going to Germany now, and the research topic that I'm going to be focusing is energy metering, where you have a live broadcast of your energy prices. And we're aiming to do that with a LoraWAN network, but with an extra layer of so we're going to look at 6P-LoWAN, where you do have the IP stack integrated in your LoraWAN network for extra security. Because the LoraWAN network is quite good, but it would be interesting to add that extra layer of security via the IP network, and that's meant for energy meters that need to get a constant updates of the. So every 5 to 10 minutes, get the energy update of the prices, and then your smart devices can decide on their own if they want to use energy efficiently now or not. But yeah, it's a valid point that you make.
Yeah, I think maybe just and I think we've done good work. We should just be very careful because of everything that we show. This is the slide that the industry take and make the decisions.
So there is an extra slide available where I listed the requirements of each of my use cases. So it is taken a bit out of context. The whole document is over there.
And I think so when you publish it, just list the attributes that you took into account and evaluate in the specific use case. Because I think there might be misinterpretation reading the slide, but I think the actual quantitative measurements, that's really the part that you need to link to this table in some way.
Okay.
Using plain English, you can.
It's not criticism on you, it's towards me, because I'm sharing that publicly.
No, so I think, because this is what this is a value for the industry. If you, let's say I'm in the business of, I want to buy sharing application and launch one in Joburg, I'll use this code to say, okay, I'm going to pick Sigfox.
Yeah.
And that's a manufacturing decision I'll make, which costs me money. And maybe there's something that I took for granted that was not included in the evaluation. So I think it's just important to quantify and list the attributes that you take into consideration. And I think there's still a lot of room for going deep into specific questions. The coverage question, the security one.
Yeah, so the network is like constantly developing. There's constantly new technologies being brought out. Like when I started, like it was completely different until now. So when I started, there was absolutely the coverage of Sigfox was really terrible. NB-IoT coverage wasn't available. LoraWAN was actually the only one that had coverage, but only in certain places in Stellenbosch. So that's why I placed the gateway. So in this 2 years, it's already expanded.
Just to give you an idea, in July, we decided to leave NB-IoT out of the study because we couldn't get it running. There wasn't coverage. And we just finally got it. Yeah. Okay, brilliant. Thank you.
Sorry, just one question. Obviously, you went to characterize your antennas that are going to be placed on each of the devices. Did your base stations obviously have all sorts of antennas? Do you characterize those or take that into account with your range calculations or your
Yes. With the maximum coupling loss, I took the base station received antennas into account as well. So I basically I know what the base station antenna is on the Sigfox gateway. I know what the base station was on the LoraWAN antenna because I actually placed that one. And then in terms of GPRX and NB-IoT, I used the commonly available GSM receiving antennas into account.
Okay. Yeah. Thank you. If there's anything else you want to know from Thomas, he's here.
Yeah, I'll solve questions. You can email me as well.
Yeah, well, you can speak to him. Thank you very much.
Can you share the presentation?
I have already emailed it. Okay, thanks.
Thank you very much, Master.